There is a horizon where everything disappears. Not just light, not just matter, but meaning itself. Galaxies flee into darkness, their glow stretched thin until it fades beyond sight. Black holes brood at the centers of worlds, swallowing stars, their horizons cutting space and time in half. Even the arrow of time, the one certainty of existence, drifts toward stillness in the far future, when entropy has consumed every flame. We call eternity forever, a vastness without end. But what if forever itself can vanish? What if the universe, infinite in scale, holds within it boundaries where infinity collapses into silence? It begins with horizons, the event horizon of a black hole, where light cannot escape. The cosmological horizon of an expanding universe, where galaxies drift away faster than light. The heat death of the cosmos, where time itself may lose meaning. Each horizon is a vanishing point, a place where eternity thins, where the known dissolves into the unknowable. Science does not shy away from these questions. Einstein gave us space-time as fabric, bending and breaking under the weight of matter. Hawking revealed that even the darkest objects evaporate. Modern cosmology shows us a universe accelerating toward isolation, where the night sky itself will someday go dark. And yet, within these vanishing points lies something profound. For in the dissolution of eternity, we glimpse not only endings, but beginnings, not only silence, but story. This is not just the science of horizons. It is the philosophy of forever, the question of what it means for time, for infinity, for us. This is the journey to the vanishing point of eternity, the birth of time. Horizons at the dawn of the universe, the silence before. What existed before the beginning? The question itself trembles with paradox. For before presumes time, and time had not yet been born. Physics tells us that the Big Bang was not an explosion in space, but an explosion of space, and with it, of time itself. There was no before. The cosmos did not expand into emptiness. Emptiness was created with it. In that first instant, a vanishing point appeared, not at the edge of space, but at the edge of time. The first second. In less than a heartbeat, the newborn universe inflated from smaller than an atom to larger than galaxies. Space itself stretched faster than light, pulling energy into existence, smoothing irregularities, flattening horizons. The furnace of creation seethed with quantum fluctuations, tiny ripples that would someday seed galaxies. As the universe cooled, particles coalesced, quarks into protons, protons into nuclei. In minutes, hydrogen and helium were forged, the first atoms, the fuel of stars yet unborn. Time ticked forward, but its rhythm was not yet stable. Gravity, radiation, and quantum fields were still wrestling for dominance, weaving the rules that would govern eternity. Einstein's revolution. For centuries, time was thought to be absolute, a universal clock ticking the same for all. Isaac Newton imagined time as a silent river, flowing evenly regardless of what drifted upon it. But in the 20th century, Albert Einstein shattered this certainty. With relativity, he revealed that time is not a backdrop, but a participant. It bends with gravity, stretches with motion, curves with space-time itself. A clock on a mountain ticks faster than one at sea level. A clock aboard a speeding ship lags behind. Time, once eternal and absolute, was revealed as elastic, fragile, dependent. Eternity, it seemed, had boundaries after all. The first horizon, cosmic light, roughly 380,000 years after the Big Bang. The universe cooled enough for electrons to bind with nuclei. Atoms formed, and for the first time, light traveled freely. This ancient glow still surrounds us, the cosmic microwave background. It is the first horizon of time, the oldest light we can see, a boundary beyond which the universe remains hid. Look farther, and we see not galaxies, but fog. It is as though eternity itself is veiled, leaving us with only echoes. This cosmic background is not emptiness. It is memory, imprinted with the faint ripples of inflation. It is the first visible edge of forever. The expansion unfolds. As billions of years passed, matter clumped into galaxies, stars ignited, and black holes awoke in their hearts. The universe expanded outward, carrying galaxies with it. Yet expansion is not flight through space. It is the stretching of space itself. This expansion creates another horizon, the observable universe. We can only see as far as light has traveled since the Big Bang, about 46 billion light years. Beyond that, galaxies exist, but their light has not reached us. The universe is larger than our vision, eternity already fractured by distance. Time is fabric, not river. Einstein's equations painted a startling picture. Space-time is not the stage, but the play. Gravity is not a force, but geometry. Horizons emerge not only in the distant universe, but in the flow of time itself. For if space-time is fabric, it can bend, twist, and even tear. The Big Bang was one such rupture. Black holes are another. In each, eternity thins into vanishing points. The human horizon. To look back toward the birth of time is to confront our own horizon of understanding. The laws of physics, as we know them, break down in the first instant. Quantum mechanics and relativity refuse to reconcile. The singularity at the beginning is not only a physical boundary, but an epistemic one, the vanishing point of knowledge. And yet, we continue to look. Telescopes trace the faintest photons. Particle colliders mimic primordial fire. Equations stretch toward unification. We cannot see beyond the horizon of the Big Bang, but we can circle it with imagination. The birth of boundaries. Thus, the story of eternity begins with boundaries. Time itself was born finite, with a horizon behind, which we cannot peer. Space itself is finite in reach, with galaxies forever hidden beyond observation. Even physics itself reveals boundaries, where relativity and quantum mechanics meet, but will not reconcile. The vanishing point of eternity is not only in the future, it is also in the past. It is the line between silence and song, between nothing and time. The black hole's horizon, where time itself disappears, the darkest boundaries. In the universe, there are places where not even light can escape, where time slows to a crawl and the very fabric of space-time caves in on itself. These are the black holes, cosmic abysses born from the deaths of stars, and yet far more than graves. They are horizons made real, vanishing points where the laws of physics falter. To peer at a black hole is to look at the ultimate contradiction. It is both absence and presence, nothingness with mass, a shadow with gravity. It is not an object, but a region of space-time cut off from the rest of reality, marked by an invisible boundary, the event horizon. The event horizon. The event horizon is the defining line of a black hole, the point of no return. Once crossed, every path, even that of light, curves inward. No signal can leave, no information can return. At this horizon, the equations of relativity describe a strange slowing. To a distant observer, an object falling into a black hole never quite crosses the horizon. Its time dilates, its motions stretch, its light reddens until it fades into invisibility. To the falling object, however, the crossing is instantaneous. This paradox reveals the horizon as more than geometry. It is a fracture in perception, two truths coexisting, each valid, each irreconcilable. The singularity. At the black hole's center lies the singularity, a point of infinite density, where space-time curves beyond measure. General relativity predicts its existence, but cannot describe its nature. Infinity is not an answer, but a failure of understanding, the place where our equations collapse. Here lies the most profound vanishing point, not just of matter and light, but of knowledge itself. Hawking's revelation. For centuries, black holes were thought to be perfect prisons. Yet in 1974, Stephen Hawking discovered they are not eternal. By combining quantum theory with relativity, he revealed that black holes radiate. Hawking radiation arises from quantum fluctuations at the horizon. Virtual particle pairs blink into existence. One falls in, the other escapes. To distant space, this appears as a faint glow, stealing energy from the whole. Over unimaginable spans of time, black holes evaporate. Thus, even the darkest eternity has an end. The information paradox. But Hawking's discovery unleashed a deeper crisis. If black holes evaporate completely, what happens to the information about what fell in? Quantum mechanics insists that information is never lost. Relativity seems to allow it. The clash between the two pillars of physics crystallized here at the edge of the abyss. Does the horizon erase reality itself? Does eternity vanish into contradiction? This is not merely a technical puzzle. It is a philosophical wound, each valid, each irreconcilable. The singularity. At the black hole's center lies the singularity, a point of infinite density, where space-time curves beyond measure. General relativity predicts its existence, but cannot describe its nature. Infinity is not an answer, but a failure of understanding, the place where our equations collapse. Here lies the most profound vanishing point, not just of matter and light, but of knowledge itself. Hawking's revelation. For centuries, black holes were thought to be perfect prisons. Yet in 1974, Stephen Hawking discovered they are not eternal. By combining quantum theory with relativity, he revealed that black holes radiate. Hawking radiation arises from quantum fluctuations at the horizon. Virtual particle pairs blink into existence. One falls in, the other escapes. To distant space, this appears as a faint glow, stealing energy from the whole. Over unimaginable spans of time, black holes evaporate. Thus, even the darkest eternity has an end. The information paradox. But Hawking's discovery unleashed a deeper crisis. If black holes evaporate completely, what happens to the information about what fell in? Quantum mechanics insists that information is never lost. Relativity seems to allow it. The clash between the two pillars of physics crystallized here at the edge of the abyss. Does the horizon erase reality itself? Does eternity vanish into contradiction? This is not merely a technical puzzle. It is a philosophical wound. If information can be lost, then the determinism of physics, the ability to know, predict, and preserve the fabric of law, dissolves. The universe itself becomes forgetful. The firewalls and holograms. Attempts to resolve the paradox have reshaped our vision of horizons. Some propose that black holes are encircled by firewalls, annihilating anything that falls in. Others argue for the holographic principle, where information is not destroyed but encoded on the horizon's surface, like a two-dimensional skin projecting a three-dimensional reality. In these visions, the black hole is not a hole at all, but a paradoxical mirror, a place where dimensions trade roles, where eternity folds back upon itself. The human horizon. To study black holes is to stand before the abyss of knowledge. They are not only astrophysical objects, but philosophical horizons, forcing us to ask whether reality itself can vanish. Einstein's relativity brings us to the horizon. Hawking's quantum vision pulls it apart. The two together reveal the vanishing point of eternity in its purest form, a place where not only matter, but meaning itself threatens to disappear, dictating the orbits of stars. But beyond them lies another vanishing point, not local, not hidden, but cosmic. For the universe itself is expanding, and with it, galaxies are fleeing beyond horizons of their own. The fleeing galaxies, the expanding silence, the discovery of expansion. In the early 20th century, astronomers turned their telescopes toward the distant sky and found a revelation hiding in islands of stars far beyond our own. When Edwin Hubble measured their light, he discovered something astonishing. Almost every galaxy was fleeing from us. Their light was stretched into red, a cosmic Doppler effect. The farther they were, the faster they receded. The universe, it seemed, was not static. It was expanding. Space itself was stretching, carrying galaxies outward like dust on an inflating balloon. A new horizon had emerged, not just the birth of time at the Big Bang, not just the event horizon of black holes, but the horizon of cosmic expansion, an edge written into the fabric of the universe itself. The cosmic tapestry. Galaxies drift not through space, but with it. Their separation grows not because they move, but because space grows between them. This expansion is not an explosion into emptiness. Emptiness itself is expanding. Imagine ink dots on a balloon. As the balloon inflates, the dots move apart. No dot is the center. Every dot sees all others retreat. So too in the universe. Every galaxy sees itself at the center of expansion. Every observer, the hub of a cosmic wheel spinning outward into silence. This vision transforms our sense of eternity. For in expansion lies the truth that the universe is not forever fixed, but forever stretching, forever changing, forever slipping away. Dark energy and acceleration. For decades, scientists assumed expansion was slowing, its momentum checked by gravity. But in the late 20th century, observations of distant supernovae revealed a deeper shock. Expansion is accelerating. Some unseen force, dubbed dark energy, pushes galaxies apart faster and faster. Its nature remains a mystery. It may be a property of space-time itself, a cosmic pressure woven into the vacuum. Whatever its essence, dark energy has rewritten the fate of eternity. Not only will galaxies drift apart, they will do so ever faster, racing beyond our reach, vanishing into horizons of invisibility. The cosmic horizon. The expansion imposes a limit, the cosmological horizon. Beyond it, galaxies recede faster than light relative to us, their signals forever lost. They are not destroyed, but they vanish from possibility. Already, distant galaxies are crossing this horizon. To us, they fade, their light stretched thinner and dimmer until it disappears. In the far future, galaxies drift not through space, but with it. Their separation grows not because they move, but because space grows between them. This expansion is not an explosion into emptiness. Emptiness itself is expanding. Imagine ink dots on a balloon. As the balloon inflates, the dots move apart. No dot is the center. Every dot sees all others retreat. So too in the universe. Every galaxy sees itself at the center of expansion. Every observer, the hub of a cosmic wheel spinning outward into silence. This vision transforms our sense of eternity. For in expansion lies the truth that the universe is not forever fixed, but forever stretching, forever changing, forever slipping away. Dark energy and acceleration. For decades, scientists assumed expansion was slowing, its momentum checked by gravity. But in the late 20th century, observations of distant supernovae revealed a deeper shock. Expansion is accelerating. Some unseen force, dubbed dark energy, pushes galaxies apart faster and faster. Its nature remains a mystery. It may be a property of space-time itself, a cosmic pressure woven into the vacuum. Whatever its essence, dark energy has rewritten the fate of eternity. Not only will galaxies drift apart, they will do so ever faster, racing beyond our reach, vanishing into horizons of invisibility. The cosmic horizon. The expansion imposes a limit. The cosmological horizon. Beyond it, galaxies recede faster than light relative to us, their signals forever lost. They are not destroyed, but they vanish from possibility. Already, distant galaxies are crossing this horizon. To us, they fade. Their light stretched thinner and dimmer until it disappears. In the far future, only our local group of galaxies will remain visible. The rest of the universe will have slipped away, leaving us in cosmic solitude. Eternity is vanishing, not in fire, but in silence. The loneliness of tomorrow. Picture the night sky, trillions of years from now. The Milky Way and Andromeda, long since merged into a single giant galaxy, shine amidst a sea of stars. But beyond them, nothing. The rest of the universe has fled, its galaxies gone, its memory erased from the sky. Future civilizations, if they exist, will see only darkness beyond their cosmic island. To them, the universe will appear static, small, eternal. The truth of expansion will be lost, hidden beyond their horizon. We are living in a privileged age, one in which the vanishing point of eternity is still visible, the receding galaxies still shining before they slip away. The vanishing light. Every galaxy that crosses the horizon is a piece of eternity lost. Its stars still burn, its planets still turn, its histories still unfold, but not for us. To us, they vanish into silence, unreachable, unseen. This is not death, but exile. A reminder that eternity is not universal. It is relative, fractured, shaped by horizons. The philosophy of expansion, by distance, by the speed of light, by the stretching of space-time. We live in a universe not of endless visibility, but of horizons that grow ever closer. To imagine eternity is to imagine loss, the slow retreat of infinity into fragments, transition. And yet horizons are not only distant, they are all around us. In black holes, in entropy, in the very arrow of time. The galaxies fleeing into silence point us toward another vanishing point, not of space, but of order. The horizon, not of expansion, but of decay. The edge of forever. Horizons that fracture infinity. The illusion of the infinite. When we look into the night sky, it feels infinite. Stars scatter endlessly, galaxies shimmer across the void, and the mind falters at their scale. Yet, edges not of space itself, but of what we can know, touch, or even imagine. These horizons are the edges of forever. The particle horizon, the beginning of sight. The first boundary is the particle horizon. It is the farthest distance light has traveled since the birth of the universe. The cosmos is 13.8 billion years old. But because space has expanded during that time, the horizon is not 13.8 billion light years away. It is about 46 billion. Beyond this lies the unseeable. Not because nothing exists, but because light has not yet arrived. This horizon is not absence, but delay. The future may reveal more, but to us, here, now, it is an edge, a vanishing point, where eternity is still on its way. The event horizon, the prison of gravity. Closer, yet stranger, lies the event horizon. We know it best in black holes, where gravity is so strong that escape is impossible. But in a universe ruled by expansion, event horizons exist on cosmic scales as well. Beyond a certain distance, even if a galaxy shines forever, its light will never reach us. Expansion outpaces photons. This is the event horizon of the universe itself, the edge not of sight, but of causality. What lies beyond it may as well not exist, for no signal, no journey, no bridge can cross. It is eternity, fractured not by time, but by speed. The cosmological horizon, the edge of memory. The third horizon is subtler still, the cosmological horizon. It is the line beyond which galaxies already flee too fast, redshifting into invisibility. We can see them now, faintly, but eventually their light will stretch beyond all wavelengths, fading into silence. This horizon is not absolute in space, but in time. It is the vanishing of the future, the slow erasure of what was once visible, a steady dimming of eternity into nothingness. Eternity in fragments. Together, these horizons reveal a universe that is not wholly ours. We live inside a shrinking bubble of visibility, surrounded by infinities we will never touch. To imagine eternity is to accept fragmentation, that our forever is not the forever of others, that horizons divide even the infinite. It is a sobering thought. The universe may stretch without end, but our share of it is small, temporary, vanishing. Philosophical reflections. These horizons challenge not only science, but meaning. If eternity is fractured, then so is our story of it. Every observer in the universe has their own horizon, their own slice of infinity. No being, no mind, no godlike observer can see it whole. Perhaps this is the nature of eternity, not endlessness, but multiplicity, not singular, but many. The vanishing point of forever is not distance, but perspective. The edge as invitation. And yet, horizons are not despair. They are invitations. For every edge we face, we stretch toward it. Telescopes gaze deeper. Detectors catch fainter signals. Theories strive for unification. The edge of forever is a limit, but also a compass, pointing us onward, urging us to imagine what lies beyond. Transition. But horizons of sight are only one kind. The deeper vanishing point lies not in galaxies or expansion, but in time itself. For time has a direction, and that direction is toward dissolution. Beyond the horizons of space lies the horizon of entropy, the arrow of time. The arrow of time, eternity's one-way road, the mystery of direction. Time flows forward. Stars are born, burn, and die. Leaves fall. Rivers carve valleys. Galaxies drift apart. We remember the past, but not the future. The universe itself seems to lean into tomorrow. And yet, in the equations of physics, time has no preferred direction. Whether run forward or backward, the mathematics works the same. Why then does the arrow of time exist? Why does eternity march one way, toward decay, never in reverse? The answer lies in entropy and disorder. Entropy is a measure of disorder, or more precisely, of how many ways a system can be arranged. A deck of cards perfectly ordered has low entropy. Shuffle it, and the entropy rises. The universe, too, began in astonishing order. The Big Bang was hot, dense, and simple. But as it expanded, it created space for disorder to grow. Entropy is the reason ice melts, not refreezes in the glass. It is why smoke disperses, but never gathers back into a flame. It is the hidden law behind every moment of irreversibility. Entropy is the arrow of time, stars, and the flow of energy. Every star is an engine of entropy. It burns fuel, pouring energy into space, driving complexity forward. On Earth, sunlight powers life, winds, and oceans. The intricate dance of biology, of civilization, of thought itself, is possible only because stars shed their order into the cosmos. But stars are finite. Their fuel will run dry. Their brilliance is borrowed against the deeper law of entropy. When the last star fades, the arrow of time will continue, but in silence. Heat death, the vanishing of motion. The ultimate fate dictated by entropy is the heat death of the universe. In this vision, stars burn out, black holes evaporate, and galaxies fade. Matter spreads thin, energy dissipates evenly. Without gradients, without hot and cold, without light and shadow, nothing can move. It is not an end in explosion, but in stillness. A cosmic whisper fading to silence. Time itself may lose meaning, for without change, what does before and after mean? The arrow of time vanishes not into reversal, but into irrelevance. The low entropy beginning. But here lies the paradox. If the arrow of time arises from entropy, why did the universe begin in such a low entropy state? Why did the Big Bang, the most chaotic of events, seed order instead of disorder? This question remains one of the greatest mysteries in physics. Some speculate that inflation smoothed the cosmos. Others suggest hidden laws we do not yet understand. Still others wonder if time itself is emergent, a property of deeper reality we have not glimpsed. The vanishing point of eternity may be hidden not only in the future, but in the past. The human horizon. For us, the arrow of time is the essence of existence. Memory anchors us to the past. Anticipation draws us into the future, fold as entropy unfolds. To imagine a universe without time's arrow is to imagine a silence beyond imagination, a place where nothing happens because nothing can. This fate is humbling. It tells us that eternity, as we know it, is not forever. It leans toward dissolution. The vanishing point is not a distant wall, but the inevitable direction of time itself. Transition. And yet, even in the far future, when stars are gone and entropy reigns, the universe is not entirely empty. Black holes remain, massive, patient, devouring. They are the last stage of order, the final guardians of gravity. But even they cannot escape eternity's vanishing point. The last black holes, eternity's final sparks, the twilight of stars. The story of the universe is also the story of light. For billions of years, stars have kindled galaxies with fire, shaping planets, oceans, and life. But stars are temporary beacons. Already, many have gone dark, collapsed into white dwarfs, neutron stars, and black holes. Trillions of years from now, the very last stars will sputter and fade. The universe will enter an age of shadows. In this future, the night sky will be darker than we can imagine. No constellations, no Milky Way, only the faint glow of dying embers scattered across infinite cold. But the universe will not yet be empty. For in that darkness, the most enduring objects remain. Black holes. The reign of black holes. Black holes will dominate the far future. As stars vanish, galaxies will quiet, leaving behind these massive remnants. Some will be stellar-sized, formed from collapsed suns. Others, supermassive, will anchor the centers of galaxies, weighing billions of solar masses. In the black hole era, they are the monarchs of eternity, swallowing stars, consuming gas, even devouring one another in silent mergers. Their horizons define the landscape of the cosmos, marking places where time and space cave inward. Yet even these titans are not eternal. Hawking's vision. In the 1970s, Stephen Hawking revealed a startling truth. Black holes radiate. Through the subtle interplay of quantum mechanics and relativity, they leak energy in the form of Hawking radiation. It is a process so slow that for stellar mass black holes, lifetimes extend far beyond the current age of the universe. For supermassive black holes, lifespans stretch to numbers so vast they defy comprehension, 10 to the 100th years or more. But however long the countdown, the ending is inevitable. One by one, black holes will fade. The death of giants. The evaporation of a black hole is almost imperceptible for most of its existence. For aeons, it loses energy so slowly it seems eternal. But as it shrinks, the process accelerates. In its final moments, a black hole blazes with radiation, releasing more power than all the stars of the universe combined, but only for an instant. Then silence. Even the giants will vanish, leaving no trace but faint ripples in space-time. The black hole information question. What vanishes with them? Here, the mystery deepens. If black holes evaporate, what becomes of the information about what fell in? Is it lost forever, violating quantum law? Or is it preserved somehow, smeared across the horizon, encoded in the radiation, woven into the fabric of space-time itself? This question is more than physics. It is philosophical. For if information can vanish, then so can memory, history, even meaning. The evaporation of black holes becomes the evaporation of eternity. The final darkness. When the last black hole dies, the universe will be vast, cold, and empty. Photons will stretch into wavelengths longer than galaxies. Matter will drift into near nothingness. Time itself may lose relevance. This is the dark era, an epoch beyond imagination, where the universe continues, but without story, without change. Eternity itself seems to dissolve into silence, the poetic horizon. And yet, there is beauty even here. For the death of black holes reveals a profound truth. Nothing in the universe is eternal. Not stars, not galaxies, not even the abyss. Everything changes. Everything dissolves. Everything moves toward the vanishing point. To glimpse this horizon is to glimpse the fragility of forever. Transition. But even as black holes fade, questions remain. Is this the true end of eternity? A silence without return? Or does something lie beyond? Theories of multiverses, hidden dimensions, or rebirth suggest that eternity itself may not end, but transform. To explore this is to step beyond physics into speculation, into the possibility of forever multiplying. Multiverse and hidden eternities, when forever multiplies. The end that isn't, the death of stars, the fading of galaxies, the evaporation of black holes, all seem to point toward silence, to a universe growing cold and dark. Yet many scientists wonder, is this truly the end, or only the end of what we? Could eternity itself split, multiply, or regenerate in ways beyond our grasp? The concept of the multiverse emerges here, at the vanishing point of eternity. It is not one universe, but many. Not one forever, but countless. Perhaps eternity cannot end, because it never was eternal inflation. The cosmos without borders. Inflation theory suggests that in the first instant of creation, the universe expanded faster than light, smoothing the cosmos. But some models propose that inflation never fully stopped. Instead, it continues endlessly in other regions, spawning new universes in bubbles. Our universe, then, may be just one bubble in an infinite froth, each with its own laws, constants, dimensions. To us, eternity seems fragile, bounded by horizons. But in the multiverse vision, eternity is inexhaustible. Forever is not vanishing, but multiplying. Yet here lies the paradox. If there are infinite universes, each inaccessible to the others, is this true eternity? Or is it an infinite scattering of vanishing points, each horizon-bound, each forever hidden? Quantum branches, the many worlds. Quantum mechanics offers another vision. In the many worlds interpretation, every quantum event splits reality. Each choice, each fluctuation spawns parallel universes. In this view, eternity does not fade. It branches endlessly. Every possibility exists somewhere. Every star that collapsed here may shine elsewhere. Every life that ended here may continue in another branch. Eternity, in this telling, is not a line but a tree, fractal, infinite, ever-branching. But even here, horizons remain. No branch can see the others. Eternity is preserved, but divided. The holographic horizon. Some propose that our universe is not fundamental at all, but a projection, a three-dimensional world encoded on a two-dimensional surface, like a hologram. If so, then eternity may be an illusion of perspective. What seems infinite in depth may be finite in code. This holographic principle offers a startling possibility that all horizons are not vanishing points of reality, but boundaries of perception. Eternity might not vanish. It may simply be written elsewhere. The cycle of universes. Other theories suggest rebirth. In models of the cyclic universe, the cosmos expands, fades, then collapses, only to explode again in a new Big Bang. Time, then, is not linear, but circular. Eternity, not a road to silence, but an endless cycle of deaths and resurrections. Here, the vanishing point of one eternity is merely the birth of another. The human horizon of thought. All these visions, eternal inflation, quantum branching, holographic universes, cosmic cycles, stretch the mind beyond comfort. They blur the boundary between science and philosophy, physics and imagination. They reveal a deeper truth. The vanishing point of eternity may not lie in the universe itself, but in us. For our tools, our telescopes, our equations cannot pierce every horizon. Perhaps what lies beyond is unknowable, not because it does not exist, but because the nature of eternity is forever to remain beyond reach. The paradox of infinity. Infinity is both fragile and indestructible. Fragile, because within one universe, it can vanish into entropy and silence. Indestructible, because on the scale of multiverses, new infinities bloom beyond every horizon. Eternity may not be a single thread, but a tapestry, woven of vanishing points, rebirths, branches, and horizons unseen. Transition. And yet, for all the grandeur of these speculations, the question returns to us. What do these horizons mean for humanity? For meaning? For our fragile span of time beneath the stars? The vanishing point of eternity may not only be written in galaxies and black holes, but in the story we tell about our place within it. The human horizon, meaning beneath vanishing skies. The smallness of us, beneath the immensity of the cosmos, humanity is fragile. Our world is a pale sphere, our lives brief sparks against eternity. Galaxies flee beyond sight. Black holes swallow the light of stars. Entropy pulls all things toward silence. When we face the vanishing point of eternity, we confront not only physics, but ourselves. What is our place in a universe that forgets? What is the value of meaning when forever itself may dissolve? The horizon of knowledge. The story of science is the story of horizons reached and crossed. The telescope revealed galaxies. Relativity revealed space-time. Quantum theory revealed uncertainty woven into the fabric of reality. Each breakthrough expanded our vision, yet also revealed limits. We cannot see before the Big Bang. We cannot peer past the event horizon. We cannot reach galaxies, fleeing beyond the speed of light. Every answer becomes a boundary. Every horizon reminds us that knowledge itself has edges. And yet, this is not despair. It is invitation. Horizons are the reason we wonder, the reason we reach, the reason we dream, the fragility of meaning. Civilizations rise on delicate balances, stable climates, fertile soils, shared stories. These balances are fragile, vulnerable to shifts in the very forces that shape stars and galaxies. If eternity vanishes, does meaning vanish with it? If the universe ends in silence, does everything we love, build, or remember collapse into irrelevance? Philosophy answers with paradox. Meaning is not given by eternity. It is created with infinitude. The beauty of a sunset is not lessened because it fades. The value of a life is not diminished because it ends. Meaning is fragile, but precisely because it is fragile, it is profound. Resilience in perspective. Snowball Earth froze for 60 million years, yet life endured. Stars explode in violence, yet planets form from their ashes. Catastrophe and creation walk together. The universe itself teaches us resilience. So too with humanity. We endure not because we control eternity, but because we find meaning within its vanishing. To live is to face horizons and still create story. The human horizon. Perhaps the vanishing point of eternity is not distant, but within us. Our awareness, our fleeting consciousness, is a horizon. Bounded, finite, yet vast with meaning. To exist is to carry eternity for an instant, to glimpse the infinite through the narrow window of a mind. Our horizon is not cosmic scale, but human scale. And yet, in its brevity, it holds the power to reflect the stars, to imagine forever, to whisper questions into the silence. The gift of finitude. If the universe were eternal, changeless, without vanishing, perhaps meaning would dissolve into monotony. It is the very impermanence of things, the fleeting, the fragile, that gives them weight. We do not need eternity to matter. We need only the horizon we have, this planet, this sky, this fragile thread of time. Transition to closing meditation. And so, the vanishing point of eternity does not diminish us. It clarifies us. It reminds us that existence is fragile, that knowledge has boundaries, that life is fleeting. But within that fragility lies the most profound truth. To exist at all, even for a moment, is to hold eternity in our hands. There is a horizon where even imagination falters. Galaxies flee into silence, their light stretched thin until it fades into invisibility. Black holes whisper at the centers of worlds, swallowing not only matter, but the very information that describes it. Time itself leans forward, its arrow carried by entropy toward stillness, where the rhythms of existence dissolve. We call it eternity, forever, infinite, unbroken. Yet physics tells us that forever is fragile, that eternity itself may vanish. From the first horizon, the Big Bang, where time was born, to the cosmic microwave background, the oldest light we can see, every step reveals a boundary. From the event horizon of black holes to the cosmological horizon of dark energy, we are surrounded not by endlessness, but by edges. Every horizon is a reminder. We see only fragments of forever. And yet, in those fragments, something profound emerges. In the vanishing of galaxies, we glimpse the immensity of what we cannot hold. In the evaporation of black holes, we see that even the strongest prisons dissolve. In the silence of heat death, we discover that time's meaning is not in eternity, but in the moments it allows. The vanishing point of eternity is not a single place, not a distant wall. It is everywhere, in the collapse of stars, in the drift of galaxies, in the brevity of a thought, in the passing of a life. It is the reminder that nothing lasts forever, and that perhaps it is this impermanence that gives existence its depth. For what is eternity, if not story? Not the endless march of time, but the telling of it. Not the permanence of things, but their reflection in memory, in awareness, in wonder. We are the universe knowing itself. For an instant, we are fragments of eternity gazing toward its vanishing. Someday, the last star will fade. Someday, the last black hole will evaporate. Someday, the universe itself may dissolve into silence. But until then, there are galaxies still burning, skies still glowing, lives still unfolding. The vanishing point is not yet here. And so we stand beneath a sky full of horizons, and we breathe, and we wonder. Eternity may vanish, but meaning does not. Meaning is now, in this fragile span, in this fleeting glimpse of forever. The vanishing point of eternity is not only an ending, it is an invitation to see the beauty of the finite, to cherish the moment, to carry infinity within us while we can.